Hello students, in this video we will be solving problems from exercise 8.4, the third question, under which we will be solving a couple of problems. Then we'll solve question number 4 from exercise 8.4, under which we will be solving 4 problems. Let's begin with the first problem under question 3, which says evaluate. The first problem is sine square 63 degrees plus cos plus sine square 27 degrees whole thing upon cos square 17 degrees and add cos square 73 degrees. Okay, now if you have a look at these two, we have to try to solve it in such a way that things cancel out and we get a very simplified answer. Now if we have a look at this, we can say 63 plus 27 gives us 90, but will that achieve us something? Maybe, maybe not. Have a look at the denominator. Here also 73 plus 17 gives us 90. So if we try to get the complementary of that by saying cos square of 90 plus 90 minus, it may give us sine square and cos square. Here also if we try to change one, it will give us in cos square. So we know one identity, that is sine square theta plus cos square theta equal to 1. So if we can show one of these as cos square, then sine square theta cos square theta will be equal to 1. Similarly over here, if we can show sine square theta cos square theta, then we can show it equal to 1. Let us see if this is possible. Sine square 63, we can show this as 90 degrees minus 27 degrees. Okay, this can be written this way. Sine square 27 degrees, will leave it the way it is. Again, in the denominator, cos square 17 degrees can be shown as 90 degrees minus 73 degrees, and we'll leave cos square 73 degrees the way it is. Sine square 90 degrees minus 27 degrees can be written as complementary will be cos square 27 degrees, and sine square 27 degrees will be the way it is. Okay, this way. And cos square 90 degrees minus 73 degrees will become sine square, the complementary is sine square 73 degrees, and this will be cos square 73 degrees. Now the angles are the same for sine and cos. Here also the angles are the same, and they are in their squares, so sum of their squares is equal to 1. So we can write cos square 27 degrees plus sine square 27 degrees is equal to 1, and sine square 73 degrees plus cos square 73 degrees is equal to 1. This identity is only possible if the angles are the same. Here the angles are the same, okay, and it is not just sine plus cos, it is sine square plus cos square. So whole thing is equal to 1. That is the answer of the first problem. The next problem is sine 25 degrees cos 65 degrees plus cos 25 degrees sine 65. So let us try and convert one of these into their complements, and same way over here as well, and see what do we get. So sine of 25 degrees can be written as sine of 90 degrees minus 65 degrees. 65 plus 25 gives us 90, and this which is multiplied cos 65 degrees, I'll leave it the way it is. Cos 25, we will convert that into cos of 90 degrees minus 65 degrees, and this will be sine of 65 degrees. Now in this case, sine of 90 degrees minus 65 degrees can be the complementary of that would be cos of 65 degrees multiplied into cos of 65 degrees plus cos of 90 degrees minus 65 degrees, the complementary would be sine of 65 degrees into sine of 65 degrees. We can write cos of 65 degrees into cos of 65 degrees as cos square 65 degrees plus sine of 65 degrees into sine of 65 degrees, we'll write it as sine square 65 degrees. Once again, the identity of cos square theta plus sine square theta equal to 1 comes into picture. The angles are the same, so we can use that identity, and the answer to this will be 1. That's the answer of the second problem as well. Now let's move to the fourth question. The first problem under question number 4 is 9 sec square a minus 9 tan square a. So there is something common between the two, that is 9. If we take that out, we are left with sec square a minus 10 square a. If you remember, we had done a video on all the formulas and the identities, and we had drawn a regular hexagon this way. Okay, let's recall that once again, and we'll put this as sine, this was cos, and this was 10, this was cot, this was cosec, and this was sec. And we had drawn, we had connected the diagonals this way, and we put a 1 in between, right? A 1 like this was put in between, and then we had got some relationship with these ratios with this 1, and one of them was going in this fashion. Okay, that is we got a relationship between sec square and 10 square. If you recall, we had taken these 3 triangles, okay, and it was in this fashion, these arrows. So we had got sine square theta, I told you, in the 7 fashion, with the tail coming first and the head coming last. Sine square theta plus cos square theta equal to 1. Then the next one we got was 1 plus cot square theta equal to cosec square theta. 1 plus cot square theta equal to cosec square theta. And this one we had got as 10 square theta plus 1 equal to sec square theta. This way, 10 square theta plus 1 equal to sec square theta. Now this, we are interested in this particular identity. In this particular identity, if I take 10 square on the other side, what will it be? 1 will remain on the left hand side, and we will get sec square theta minus 10 square theta equal to 1. What do we have over here? Sec square a minus 10 square a. The angles are the same, which means we can write this equal to 1. So this will become 9 into 1, which is equal to 9. Okay, so here you can write, since sec square a minus 10 square a equal to 1. So it helps if you remember the identities, or at least draw this regular hexagon and remember how we deduced or got all the trigonometric identities. Let's move to the next problem. The next problem says 1 plus tan theta plus sec theta whole thing into 1 plus cot theta minus cosec theta. What I see common between the two, what I get, first step that I can see is tan is sine upon cos, sec is 1 upon cos, which means the denominator will come as cos in this bracket. Here cot means cos upon sine and cosec means 1 upon sine, which means in this bracket sine will be the denominator. So let us try to do that first. Let us try to simplify this bracket. 1 plus tan theta, I am writing it as sine theta and cos theta. Okay, let us simplify it first. And sec theta can be written as 1 upon cos theta, because sec theta and cos theta are reciprocal of each other. Whole thing into, we'll apply the similar steps over here. Cot theta can be written as cos theta upon sine theta, and cosec theta can be written 1 upon sine theta, because they are reciprocal of each other. Now let's take a LCM. Here clearly you can make out the denominator has, or the LCM has got to be cos theta. So here cos theta will come instead of 1. Here it will be sine theta, and there will be 1. Whole thing into cos theta. I mean whole thing upon cos theta. Here you will have sine theta coming in place of 1, because the LCM will be sine theta. Here cos theta, and you will have, sorry, here there will so here there will be minus 1, and that will be sine theta upon sine theta. So we have come to this point now, and now what we'll do further is Now I'll multiply this entire bracket into this one. So our big line over here, so cos theta into sin theta will be just sin theta into cos theta. That will be our denominator. Cos theta will get multiplied into this entire bracket. So cos theta into sin theta gives us cos theta sin theta. Cos theta into cos theta gives us cos square theta. Cos theta into minus 1 gives us minus cos theta. Then sin theta into sin theta gives us sin plus sin square theta. Sin theta into cos theta will give us plus sin theta cos theta. Sin theta into minus 1 gives us minus sin theta. These two are done. Now 1 has to multiply into this entire bracket. 1 into sin theta gives us plus sin theta. 1 into cos theta gives us plus cos theta. And 1 into minus 1 will give minus 1. Okay. Now can we cancel out anything over here? That is what we need to see. Clearly you can make out minus sin theta plus sin theta cancels out. There is a minus cos theta and there is a plus cos theta. That also cancels out. Now there is a cos theta sin theta positive and there is a sin theta cos theta positive. Both are the same. Doesn't matter whether it's cos theta sin theta or sin theta cos theta. We can write this as 2 cos theta sin theta. Okay. So these two are taken care of. Then we have cos square theta plus sin square theta. We know sin square theta plus cos square theta is what? 1. We can write that as 1. And we have taken care of this and this as well. So are we left with anything else? Yes, we are left with a minus 1 over here. So minus 1. So this is also done, this is done, this is done, this is done, this is done. So we have been taken care of everything. Whole thing upon sin theta into cos theta. Plus 1 minus 1 cancels out each other. Okay. And then we are left with, I'll just conclude it over here. We'll be left with equal to sin, we will put 2 cos theta sin theta whole thing upon sin theta cos theta. Then we can easily cancel out this sin theta cos theta. We are left with 2. That is our answer. The next problem is sec a plus tan a whole thing into 1 minus sin a. Once again, let's always try to see if we can simplify complex trigonometric ratios. So sec a can be written as 1 upon cos a plus tan a can be written as sin a upon cos a. You see the denominators are the same, and here this will be just 1 minus sin a. Now we can add them up, 1 plus sin a upon cos a whole thing into 1 minus sin a. Okay, so that's a multiplication. So we can multiply 1 plus sin a into 1 minus sin a, and that is a plus b. This can be a plus b into a minus b, and that answer a plus b into a minus b gives us what? A square minus b square, right? Whole thing upon cos a, and this we can write as 1 minus sin square a upon cos a. And just conclude the problem here. Equal to sin 1 minus sin square a, from our identity we know it is equal to cos square a whole thing upon cos a. So cos a and the square cancels, we are left with just cos a, and that is our answer. The fourth and the final problem for this video is 1 plus tan square a upon 1 plus cot square a. Once again we'll look to simplify it. We'll write 1 plus tan square a, we can write it as sin square a upon cos square a. The whole thing upon 1 plus cot square a, we'll write it as cos square a upon sin square a. Now we'll take our LCM. So this one will become cos square a plus sin square a whole thing upon cos square A, and in the denominator here the LCM tells you that it is sin square A. That should be the common denominator. So instead of 1 we have sin square A plus cos square A whole thing upon sin square A. Okay, I'll conclude it over here, equal to sin. Now cos square A sin square A, we can write it as 1 upon cos square A, and again we have sin square A plus cos square A in the denominator, so that will become 1 whole thing upon sin square A. Now if we multiply this thing from division, it will become this way, 1 plus cos square A into whatever is the denominator will become the numerator, and what is the numerator will become the denominator. This sin square A upon cos square A, and we know sin upon cos is 10, so we can write this as 10 square A, and that is the final answer of this problem. So we have solved question 3 and 4 from exercise 8.4 in this video. If you have liked the video, please click the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon to receive notification whenever a new video is posted. Thanks for watching. See you in the next video.